Hello, and today we're looking at soil fertility, or parts of the soil that make it fertile, should I say. So, to start with, then we'll look at soil components in a general overview, and then we'll look at water content, soluble inorganic nutrients, pH, air content, dead organic matter, soil biota, and then the last three we'll do on our next lesson. So, to start with, then, our soil is not just this sort of brown mass that we are used to seeing, or various colors. So it's made up of lots of different parts. So if we took some soil and really zoomed in and had a really good look at it, we'd see that there are some large particles in it. And then there would be some much smaller particles of different sizes and shapes interspaced within them. And then we might even see tiny additional particles as well. And all of these tiny particles, these medium-sized particles, these large particles, are particles of weathered rock. So we're thinking the large ones are sand particles. The sort of medium-sized one are particles of silt, and the tiny ones are clay. Okay, and there are three fractions of our soil. We then also have things like water, sort of attached or around our particles. That's very important. We've got air gaps within this. And we've got dead organic matter floating around in there as well. So these are sort of blobs of like black matter. So that's our dead organic matter. And then we also have our biota. So this could be things like bacteria or single-celled organisms. We might have worms of different sorts and varieties. We might have roots of plants. We could have hyphae from funguses. So this all adds up to being our biota. So plants, algae on the surface, insects, worms, fungi, bacteria. All of this adds up to make our biota. Now, all of these features together are worked together to make our soil fertile. So this gives different proportions of these things give us our fertility. Okay, and fertility is the ability of soil to support plant growth. And from that, we can then grow our crops and feed ourselves. So what we got to look at then are some of the features of soil fertility. So our first one then is water content. So plants need water to be a solvent so that they can absorb dissolved nutrients. And we sort of talked about how important water was at the start of the course. They need it for photosynthesis. So it's pretty important for that. And they need it for transpiration. So this is for transport of these dissolved nutrients from the soil up to where they're needed. Now, if we have waterlogged soil, that is too much. Because that is then anaerobic. And you get things like denitrifying bacteria, which reduce fertility. But you also get, it'll kill the roots as well, because most plants are not adapted for anaerobic conditions. So what we want is the roots, the soil to be moist but aerated, so that they are aerobic. All right, and the water in the soil falls into a couple of different categories. So if we have our particle of sediment in our soil, we find that we have hygroscopic water that is adhered to the particle. So adhered to particle, and this makes it unavailable for plants, and that was called, let's get it down there, hygroscopic water. Okay, we also then have our capillary water. And that is stuff that's been drawn close to the particle in our soil. So this doesn't drain easily. Because it's held tightly, but it's not too tightly held. And this means that it's available for plants. And then the last one is gravitational water. So gravitational water is easily drained. So it can be lost easily, but it's also available for plant uptake. And different fractions of different particle sizes will affect the different types of water you find in our soil.